Thank you, Priya, and thank you, Djangonaut, for having me. I'm happy to be sharing a bit more details on the ORM and trying to demystify a bit how it works. Before we start, my name is Charette. I'm based in Montreal, Canada, and I've been contributing to Django for about 10 years now. I mostly to the ORM and migration nowadays because it's the field that interests me the most. But otherwise, I started with, as Priya said, with translating strings and making changes to forms and content types and so on. And I slowly got into the ORM and migrations because where I was working at, we were using a lot of Postgres specificities that required me to tweak the ORM a bit and make changes. And I just got hooked to fixing bugs and making reviews around it. I'm currently employed at Zapier. It's an automation company as I'm a principal engineer there. So before we start into looking into the Django ORM specificities, I think it's worth taking a bit of time talking about what an ORM actually is. The acronym ORM stands for Object Relational Mapping or Mapper. And it's a paradigm that is often used in programming language that support the object-oriented design. So if you're able to define classes, you will be what would be more easy conceptually to map classes to database tables and map instances of these classes to rows of the table. If that's a bit confusing to you, we're going to go over a few examples, but that's one of the reasons why this paradigm is often used in object-oriented programming. The ORM allows you to interact with the database to retrieve and update data. So that is selecting it, aggregating it, inserting new data, updating it, deleting it as well. And in the case of the Django ORM, and I guess other ones that are written in Python, it allows you to map table rows to Python objects. So what does it look like concretely in the case of Django? If you define a model subclass, in our case, we have the author class here, and you define a field on it. You will, when you run migrations for this particular model, Django will create a table for you. If you're not familiar with what an SQL table is, it's a way to represent data in a tabular form. So just like you would define an HTML table where you have some columns that define what is exactly in each row, or if you use tabular software like Excel or Google Sheet, it's relatively the same concept where obviously the SQL level allows you to define more constraint and relationship between some of your tables, but it's tabular data. So you have columns that define what exactly you will see in each row for this particular column, and you have an association with it. So in this case, you can see that there are some repetition of fields. So in this case, author model is mapped to the table name author, and the name field is mapped to the name column in the SQL definition. How is data stored in these tables? So if we use the author.objects.create, if you use the ORM a bit, you might be familiar with this method. It allows you to create objects. So you pass the exact fields that you define in your model, and this will translate to this insert into SQL query that gets then stored on the database server, a bit like you see on the ID name table there. So in this case, the ID is implicit because it's the default one that Django provides, but that's the way the query gets translated. Again, you can see that there's a bit of like similarity here, right? You see that the model name is mapped to the table name, and the literal the name column is wrapped in the column that's going to be inserted, and the literal value, Carlton Gibson as well, a well-known Django contributor, is passed as a literal value in the SQL query. Data is retrieved using an SQL statement. So that is the select one in this case. If you do something like author.objects.filter by name again, Carlton here, that's going to result in this particular SQL, and you're going to get back instances of author through that, matching your actual query. So that's kind of like a small primer on how the ORM maps it to SQL, but the intimidating part often lies or is perceived to be in how does it's actually turn into SQL, right? It seems kind of like simple there. You could see there's mapping, but the ORM allows you to do so many things. I think that over the years, the one conceptual model that has helped me reason about the ORM is to see it in a sequence of phase. So 4 phases in this case. So in order to understand it better, we'll go over each phase individually. The first phase is the resolving phase, followed by the compilation phase. What is actually compiled, it then gets turned into, gets passed and executed against the server, and then it's constructed back into model instances. So let's start looking at by looking at the resolving phase. The resolving phase is maybe one of the phases you're the most familiar with. It's the phase where query sets are kept lazy. So you can chain operation against them. You could do multiple filter call. You could use the only method, annotate, name it. Any form of query set method that keeps returning a query set, it can be considered to be in the resolving phase. So what exactly happens during the resolving phase? So the resolving phase is the phase where when you pass keyword arguments to filter, or you pass specific field reference to annotate and so on, the ORM will validate that the value that you're passing as your filter is valid. So if you're trying to match against an integer field, for example, you're passing a string, the ORM will tell you during the resolving phase, that doesn't make sense. You cannot filter against an integer with a string value. And all of this logic happens through a method called resolve expression. So each components or abstraction that can be passed to the ORM and is able to resolve column and resolve literal value has a method on it called resolve expression. So if you search for this particular name in the code base, you will find a few classes that implement it. The idea behind it is that you've got an object, it's completely standalone, it has a resolve expression method, and it accepts a query. And what the object should return when the function is called is an object that is resolved within the context of the provided query. So let's take an example here. If we look at author.objects.filter name, Cotton Gibson, what we saw previously, what the ORM does under the hood is that it creates a fname object based on the keyword argument name that you've passed, and it calls the resolve expression method on it, and it's going to resolve the fname instance in the context of the author query. So the field name by itself doesn't mean much, but if you resolve it within the context of an author, the ORM is able to map it to the actual column from the author table. So what will get returned is a call instance. If you try to pass something that doesn't exist or doesn't make much sense in the context of author, so for example, in this case, missing, the ORM will tell you, raise a field error telling you, well, I don't know what you mean by that. There's no missing field on the author model or on any of its relationship. The resolving phase is accumulative, so you can chain methods over and over again, and more resolving will happen. So this is kind of like a simplified example of what would happen here. So in this case, we pass a filter and we pass order by. We use a lookup on name, so we do name that start with. And this is going to be turned into an accumulation of where criteria over again, the more filter call you make. And the ORM will build a structure of Python objects from resolvable to another kind of object that we will talk about called compilable. So in this case, you can see that we've got the name and start with, that's being turned into a class. Starts with, in this case, it's a lookup, and it has two components, the column and the literal value that you pass for it. And a similar picture for order by. So if you specify order by, the query set will get more and more expression. In this case, it will create a F field again, a F ID F instance with the ID parameter, resolve it, and as we've seen when we do so, we get back a call instance when we do that with an F instance. So a small summary of the resolving phase. A resolvable is a Python object with a resolve expression method. It accepts a query object to resolve itself within the context of the query, and it returns a compilable. We will look into what a compilable means in a moment. This phase is accumulative, so during that phase, the query set remains lazy and more resolving can occur. But more importantly, nothing gets to the database yet. It's more of kind of like a phase where you build a query set and you define it. If you look at the code base, most resolvable are subclasses of DjangoDB modeled expression. So this is kind of like a protocol of some form, the old resolvable idea, but it's you can subclass expression and implement the right method, and you will get what you need out of the box by doing that. And most of the resolvable are composed of other resolvable in a nested fashion. So what does that mean exactly? The way things are structured in the ORM, the only thing that really needs to be resolved are field reference. So everything else are kind of like container of field reference or of literal value, and they can be nested on top of each other. So for example, we saw that the lookup was a resolvable itself, but it was composed of other resolvable that were nested into it. So you kind of got this nested structure that allows you to represent very complex queries. And most importantly, this phase is backend agnostic. So what I mean by that is that at this point, there's no logic that is SQLite or Postgres or MySQL specific. You're building a representation of a query that is an intermediary representation that is tied to the ORM, but it's not something that is specific to SQLite or Postgres or MySQL. So we looked at the resolving phase. What comes next is the compilation phase. A compilation phase, if you want to summarize it, you take a resolvable and you get back a string representing SQL and parameters. That's what it does. So you start from a query object and you turn back into a string SQL and params. This phase is triggered by any non-lazy query set operation. So any operation that would not return a query set. So for example, get, aggregate, update, first, like all of these methods that actually get to the database triggers the compilation because the query needs to be turned into actual SQL to get executed. When it's triggered, the proper settings of database entry is determined from routers. So depending on which model you're writing to, the right database backend is going to be picked. So it could be Postgres, SQLite, whatever you have defined there. And depending on the type of operation you're asking for, so an aggregation, an update, an insert, a different compiler will be used because different kind of query needs to be generated. It could be a select statement, an insert statement, and so on. And just like resolving, the compilation phase is recursively compiles its constituents. So you could have like a compilable that contains other compilable, and it stitches all the SQL together in a kind of like nested fashion. So we've seen that a resolvable is a Python object with a resolve expression method on it. Well, a compilable is a Python object with a asSQL method on it. And what this asSQL take as parameter is the connection object, so a connection to Postgres and so on, and the compiler object, which determines which kind of operation you want to compile this expression for. So in the case of call, which is resolved from F instances, You get past a connection in a compiler, and you get returned a reference, so actual SQL that can be used that reference the column. In this case, you see the table name is wrapped in quotes, and the column as well. In the case of a column, there's no parameter, so there's no literal value that we want to pass to the backend. So the params with SQL is an empty tuple. If we look at the starts with lookup, being past the column and the literal value, when it compiles, it's going to be recursively compiling its constituent. So in this case, as we've seen, when we pass a call, it's as SQL gets compiled to the left-hand side. So the part on the left-hand side of the like in the SQL, and the literal value Carlton in this case gets compiled to a parameter S holder, so the percentage sign S, and the name itself is a parameter because it's a literal value that we want to pass down to the ORM. So we touched a bit about it, but how do resolvable and compilables relate to each other? So a resolvable resolve expression method must return a compilable. A resolvable object can also be a compilable. So it's possible to define a class that implements both protocol, that has both resolve expression on it and has SQL on it. And in practice, most resolvable objects are also compilable because they don't need to have anything special regarding their resolving. So they can return themselves with their constituent, or what is called their source expression, turned back into a resolved compilable themselves. And from there, you're able to implement both protocol on it. And if you look at DjangoDB models expression again, this class is both a resolvable and a compilable. Well, the compilable part is more of a stub, so you need to actually implement it. And that's what most of the subclasses of it do. A kind of like overview of how the quarks, or what is also often referenced as the d under syntax, gets turned into under the hood. So we've talked a lot about expression compilable and resolvable, but the reality is that a few years ago, that was not the case. It was not possible to extend the ORM at all to do these kind of things today that you can do by using creating your own lookup classes, or creating passing around the func instance and so on. And previously, the only way to actually do lookup was to use this syntax, so name underscore start with and Carlton. And but today, what this is equivalent to is, if you look at how if you use the name that underscore start with syntax, it's pretty much an equivalent of importing the starts with lookup and passing it directly to filter with fname and var Carlton. But the reality is that it's way more practical, and it's kind of like nice syntactic sugar to be able to keep using this Quartz syntax, right? You don't have to do any import, you don't have to do class creation. It's way more readable, but it's important to remember that at this point it's more like a shorthand over importing all of these objects yourself and doing it, and it's quite more it's easier to read and reason about. We talked a bit about resolvable that resolve to themselves. Well, literal value are a good example of that. So if you pass an integer or a string or a datetime or anything that is not tied to a field reference or anything like that, in the case of like the value class, which is a subclass of expression, it's a resolvable and both a compilable. If you resolve 42 in the context of a query, well, it doesn't change anything, right? Because it's 42, right? It's not tied to any table or anything like that. It's just like a literal value. If you compile it though, you get back this placeholder and the parameter, as we've seen. If you've used the func instance, which allows you to call arbitrary SQL function, you can see that things are a bit more different here. So if we pass func and we pass a fname instance and we resolve it, we can see that we get returned another func instance. So in this case, func is both resolvable and compilable, but you can set its source expression, so its constituents were themselves resolved. So in this case, f was resolved to call author and name. And if we were to compile what gets returned, you can see that now func is wrapping the SQL of its call within the function name that you've provided. The last piece of the puzzle with regards to query compilation are the compilers themselves. So we've looked at how bits of SQL can get compiled, so things that you're passing around and so on, but you need the whole skeleton around the query as well to be set up. So in the case of create, update, and delete, they result in vastly different queries. Insert syntax and create and update syntax and delete syntax have very different ways of structuring the table reference and how fields must be passed and so on. So we have specialized compiler for them. They all inherit from SQL compiler, so you could have a look at it. But the basic idea there is that what the SQL compiler is in charge of is stitching all the bits together. So we've looked at how columns reference can get compiled. Look at how lookups, so things that result in the where clause get compiled. But if we want to look at like a simplified example of how a SQL compiler is going to be turning field reference into SQL, you can kind of like think of it using this pseudocode where when the SQL compiler is asked to produce the exact SQL that eventually is going to get executed, it's going to use some sort of like interpolation where it's going to compile every column that it needs to select by calling compile, which translates into calling as SQL on all of the fields that have been resolved, so all the call. And we'll collate it together and make sure to prevent SQL injection by not combining params and SQL itself, delegating that to the backend, which is part of the execution phase. So we reach a point in our query where we resolved it. We're sure that it's something that makes sense of the ORM perspective. Now we're at a point after compilation where we've got the actual SQL string and its parameter, and we want to execute the query. So the execution phase, it's from the Django's perspective, a lot happened on the database backend, and a lot of it happens in the actual driver that you've installed. Python came up with an interface for how these drivers should be defined. It's PEP 249. You can have a look at it. It's pretty old at this time, but it's still very relevant. If you're using Postgres as your backend, you most likely using PsychoPG as your driver or backend Python backend SDK. I'm not sure exactly how to say it, but in this case, what this layer does is it accepts SQL and params, and it's going to do two things when you do so. When you execute the SQL, it's going to be returning you a list of tuples. So the data that you selected, what the query actually returns you in the form of like a list of tuples, or it's going to raise an exception because the query that you've executed is invalid, or the state in which the database received it is incoherent, and so on. There's a lot of exceptions that could be raised, but we will focus on the happy path here. So what does it look like exactly? Now that you've compiled the result, you can create a cursor from the connection. So when the ORM wants to execute a query, it's going to resolve it, execute it, and when it has compile it, and when it has its compiled SQL, it will execute it against the cursor of the connection that your query was mapped to. And what the backend will return is, again, either an exception, or it will return a list of tuples, so a list of kind of like all the rows that you match your select statement, or if you use something like insert and returning, you're going to get result. If you use update, it's going to be the number of of rows that were updated, and so on. But ultimately, you're going to get a list of tuples. A lot of stuff happened there. Obviously, you're kind of like defining how you want things to do, but it all happens on the database server. So that's not going to be covered in this talk, but the SQL, you send it to the database backend. It does all of its magic to actually get the tuple efficiently based on the index that you have and so on. And in the case of Django, we only care about writing, well, compiling the proper SQL for the backend and getting back result. Everything else that happens on the other side is none of our business. And when you are done executing comes the last phase. So what I like to call the construction phase. So you get back tuples, but in most cases, you don't want tuples, right? You want model instances. You want to be able to reflect about your data in a way that kind of like maps the reality of your data that you defined through your models. So how does that happen? When the tuples get returned from the backend, we're going to need to construct the actual return type and coerce as well the value that are returned. Depending on if you use alt, values, or values list, a different kind of collection will need to be returned as well. If you use values, for example, it's going to be a list of dict. If you use values list, it's going to be a list of tuples. If you didn't use anything, it's going to be a list of model instances. So two things happen during the construction phase. One that gets often overlooked is the coercion phase. So what does coercion mean exactly? It means to convert from one type to another type. Good example of that, SQLite doesn't have a native type for date times or dates, for what it's worth. So all of them are stored in strings in the database. But when you interact with SQLite and you store datetime instances on your model and so on, you don't want to get back strings, right? You want to get back datetime objects. So since SQLite doesn't have this notion of date times, we need to have a small layer that is able to take the strings returned from SQLite and turn them back into datetime object. The same thing happened for the JSON field. Even if it's stored as JSON and able to be manipulated by the database backend as JSON on the backend, when it gets turned back to Django, it's in a string form. So it needs to be turned back into actual JSON structure. And the way you do that, JSON is transmitted as string over the wire, and we do a JSON load, and we use the decoder that you might have defined on your JSON field. Similar picture for Boolean on MySQL. MySQL doesn't have a Boolean type. Under the hood, it uses tinyInt, which stores 1 bit, either 1 or 0. And in order to make sure that this detail doesn't leak through, one of the goals of the ORM is to abstract the kind of like backend that you're using under the hood. We turn back the integer into a Boolean. And this is done by using the from DB value. So if you've defined your own field class in the past, and you needed to override from DB value, that's the reason why it happens during the construction of model instances. From DB value is going to be called. And lastly, now you've got all the tuples with all the types that are converted, coerced to the right value, the one that you expected based on your model. We're going to turn it into the right iterable type. So in the case of the values, well, you want an iterable of dict. So in order to do that, you need to create dicts that map the fields that you've passed to values to the actual tuples together. In the case of values list, well, it's pretty simple on the recent version of Django because we make sure that the order that you specified in your select, in the field that you've passed to values list is going to be the exact order that we use when we do the select. So it's going to be very fast, no conversion. The exact tuples that are returned from the database are going to be returned. So if you need to deal with a lot of data, usually values list is the way to use it, the way to make it use as little memory as possible. Lastly, if neither are used, and each tuple is turned into instances of the queried model. So if you're querying for author, we're going to be turning them into outer instances. And a simplified example look a bit like that. So model classes have a class method on them called fromDB. And what this fromDB method requires is the database against which the query was performed. This is important because each model instances is tied through the database that it was retrieved from for possible further interactions with the model instances. The map of fields that are going to be specified, and the actual tuple that was returned from the database. So in this case, it would create an outer only with the ID field, and ID being 1 for the first instance. FromDB is the one that is in charge of calling FromDB value for all the value, if I remember correctly. And when this happens, well, the model instances are going to be created, and all the fields that are not specified through the second argument, this method, are going to be considered to be deferred. So this is going to go through the outer init method and so on to initialize the field and send the appropriate signals, and return a query set with all of the outers accumulated in a list that is tied to the query set called the result cache. So summarize the 4 phases that we've seen. Resolving. Resolving is lazy. We accumulate. We validate that the input are right in a backend agnostic way. So there's no logic about Postgres or SQLite here. Compilation. We turn back this resolved query in a recursive manner in a SQL string and params that are meant to be passed then to the backend driver to be executed. So we transmit the compile query and we delegate most of the logic to the driver, so PsychoPG or your MySQL driver of choice. We delegate all that to the database. The database gets back to us, assuming we hit the happy path. So the database was in a valid state and was happy to treat our query and return the data, which is the case most of the time. The tuples that are returned are going to be coursed to the proper expected type to avoid any abstraction leak from the database implementation, and the proper iterable type. And then you have your query set that is nicely built, and that is all. So yeah, that was a lot, but I think that the important part there is that if you can think of query set generated by the ORM in these 4 phases, it might make it easier to reason about how things are structured. So there's a lot, but if you approach it by different layers, it makes it a bit easier to reason about the whole thing. So yeah, thank you for having me, and I'm happy to take questions if there are any.
Amazing. This was such a deep dive into ORM. That was amazing. So yes, let's have the questions, or how I'd say it, the query sets for today. So please feel free to turn on your mic after raising the hands, or maybe put it in the chat. Okay, the first one is Rahmat. So yes, please.
Okay. Thank you, Simon. It was a very interesting session. So I'm a bit curious about how the get or create method works, like through the whole, like, can you like explain how the get or create method works using like these 4 steps that you've explained?
Yep, that's a good question. So get or create is a mix of 2 things, right? You want to retrieve data, and assuming it doesn't exist, you want to try to insert it. So you want to make sure that whatever happens, the row will exist in the database, and you will get something back out of it. So the way it's implemented, it's not a lazy method, right? It's not returning a query set, so it will perform a compilation. So you pass 2 things to this method. There are a few fields that define the ones that you want to do the lookup against. So fields that you want to make sure that you have a unique constraint defined on it, and the defaults, which are going to be used for insertion purpose, assuming the row is not found. So the way get or create works, it's going to try to do a select against the value, and assuming it cannot find it, it will create the row. And so it's kind of like a mix of two things, a get and a create. And depending on which operation is used, the right value is going to be returned. There's a bit of like semantics around locking and how, I guess, the isolation level of your database is used there, and how to deal with integrity. I don't think we need to go into that. But yeah, it's a composite of two operations, basically, a get and a create. It's just that if you write your own by doing if get, if object does not exist, create, you're most likely not going to do it right with regards to the semantic, because it's very hard to do it right, because there could be race conditions. So between the time that you do the actual get and you want to do the create, there could be another request that tries to do the same thing. And in between your get and request, well, it's possible that it might have already been inserted by another request. So yeah, it's a composite of get or create. And if you need to ensure that data exists, you want to use this method instead of rolling out your own, because it's very hard to do right.
Okay, thank you.
The next question we have in the chat from Abdul Basio. The first question is, in the resolving phase on page 9, you mentioned F name. What is F? Could you please give an example of author query?
Yeah, so F name, if you use the ORM and you try to reference field, F is a shorthand for field. So it's a field reference. So if you want to make a reference to a field, you're going to be using F object. In the case of what exactly is a SQL query, you can think of it as a lower level query set. So a query set has a query object, and it's what it's used to accumulate all the result thing that you've had over your different filter calls. It's bound to the query set model. So yeah, to summarize, F means field, and SQL query is a under the hood object of query sets.
Hope it answers your question. The another question is again from Abdul Basio. Lazy resolution. What do you mean by lazy, please?
Yeah, so if you use query set, you might have read from the definition that they're lazy. What it means is that if you define them at the module level, or if you defined particular fields, or I guess Django REST framework serializers, you can define the query set by themselves doing filter call, but until you try to iterate over them, so with a for loop, or you try to do a get on them, it's just a declaration of the query. It's not going to be executed by itself. So by laziness, I mean, it's not going to reach out the data eagerly. It's going to be more declarative.
Hope this answers. Next question is very interesting from Alex, and that is, what would you change in the ORM if you could break compatibility? Anything in it that you would do better if it could be changed or rewritten?
It's a good question. I think there's a mix of things. I think that there's, I guess, I think that the way we still depend in a lot of areas on connection to take some shortcuts. So I said that the resolving phase is completely database agnostic, and it's true in like 99.9% of the case, but there's still some cases there that predate the introduction of multiple database support and router and so on. And they use the default connection to make some decision about how things should be resolved. I think this is something we should fix, and I think this is something we will have to fix if we want to get fully into async. And the reason is that some of this logic is tied to what we call features associated with the database. So when you define a database backend, you can define which features it supports and which features it does not. And depending on that, different SQL is going to be generated. Well, in this case, sometimes when you try to retrieve some features, you need to reach out to the database to know which version it is. And that's I/O. You need to talk over the network to do so. But if you want the resolving phase to be truly lazy and don't do anything that is I/O, because we want to move to async, for example, and we can't do that, block the event loop during that time, we need to figure that out. And I think that's something that flew under the radar for a long time. But as we get closer and closer to the getting to an async ORM, we will have to figure out what we want to do in this case.
Wow. Such a great answer. So yes, the next up we have Yash. Yes, please.
Oh, I cannot hear you, Yash.
I'm audible.
Yeah, I can hear you now.
Yeah, so like for the past week, I've been trying to contribute into like trying to understand Django ORM and the whole code base. I came to this thing like when I was working on this issue atomic of adding support of atomic upserts. I picked on that issue and I was working on it, and I got to know I took a deep dive into how Postgres works internally and Django ORM how is working. I got to know about the row level locking system, which you just also said now. So I got to know Postgres by default supports it right now. But I also got to know Django ORM itself supports it. I was not getting one thing that if already Postgres a database supports it, the whole then why are we like getting things done through like the Django ORM? Why not like let the database handle it? Because I think the work most of the times, from my point of view, for the past 1 week research, I feel like things are mostly done on being done on the application layer. That's what I just want to know why the like importance of row level locking in Django ORM is being needed, because I guess most of the other databases, MariaDB, MySQL, Postgres, I researched a little bit, they all support it by default. So that was my question.
So you're talking about things like the usage of like explicit usage of select for update, for example, for row level locking. Yeah. So we use that in a particular area. I think it's one of the areas we use it is in update or create, if I remember correctly. And we use it there because if you are to make some alteration in memory within your application, you need to lock the row for that during that time. The reason is since the alterations are made in memory in order to prevent racing calls, so other calls that would try to update the row, since you're not updating all the fields, you want to kind of like prevent that from happening. So if you want to look at an actual reason why it's used, what I would suggest you do, and this is something you can do for a lot of questions that you might have around code in the ORM. Use the git blame feature in GitHub, where you can see, oh, which change actually introduced this. Why do we use it for update there? Right? You look at the line in particular, and Django does a very good job at linking back to tickets and linking back to pull request discussion. So in this particular case, if I remember correctly, it's because it could be a race condition and we want to prevent it from happening. But if you do a git blame, you'll be able to walk back to the pull request and walk back to the ticket and see all of the discussion. It might even link to forum or developer mailing list discussions. So that might be easier to understand why it's there. A lot of the time there's things in there that seem like out of order, right? Why exactly we're doing that? But yeah, if you go through the historic background, it might explain it a bit better. Sorry. Does that answer your question, Yash?
Yeah, kind of. I also had this conversation with my mentor in the Django program, and we also he also we came to this conclusion only that I think because over the time, like previous databases might not have supported it like previously. That's why this was present. But now, like as all the databases are developing, they are being open source and all. I think they all have the speech feature now. So obviously, ORM is very uncertain. That's what I got to know.
Okay.
Thank you so much.
Okay. I'll stop the recording now and then we can pick up more questions. Okay.